What if everything you thought you knew about reality was just the tip of the iceberg? What if, beyond the stars and galaxies we see, there are countless other universes, each with its own version of you, living out every possible outcome of every decision you've ever made? This isn't science fiction, it's a theory that some of the brightest minds in science are seriously considering. Welcome to the mind-bending world of parallel universes. For centuries, humans have gazed at the night sky, wondering if we're alone in the cosmos. But what if the question isn't just about life on other planets, but about entire other realities? Scientists have uncovered not one, not two, but 25 compelling reasons to believe that our universe might be just one of many. From the strange behavior of particles at the quantum level to the mysteries of black holes and the vastness of cosmic inflation, the evidence is stacking up. In this video, we'll take you on a journey through these 25 reasons, exploring how cutting-edge theories like quantum mechanics, string theory, and the holographic principle are reshaping our understanding of reality. You'll discover how the laws of physics might not be as universal as we once thought, and how the very fabric of existence could be far more complex and far more fascinating than we ever imagined. So, are you ready to step beyond the limits of our universe and explore the infinite possibilities of the multiverse? Stay with us, because by the end of this video, you'll see the cosmos in a whole new light, and you might just question everything you thought you knew about reality. Let's dive in. Now, let's take our first step into the multiverse with a concept that might sound like it's straight out of a sci-fi movie, but is actually rooted in some of the most advanced science we have today: quantum mechanics. At the heart of this mind-bending idea is something called the many worlds interpretation. Here's how it works. In the quantum world, particles don't behave like the objects we're used to in our everyday lives. Instead of following predictable paths, they exist in a state of probability. For example, an electron might have a 50% chance of spinning one way and a 50% chance of spinning the other. But here's where it gets wild. According to the many worlds interpretation, every time a quantum event occurs, the universe splits. In one universe, the electron spins one way, and in another, it spins the opposite way. This means that every possible outcome of every quantum event actually happens just in different universes. Think about that for a moment. Every decision you've ever made, every random event that's ever occurred, could have played out in countless other ways, and somewhere out there, those other versions of reality exist. The implications of this theory are staggering. It suggests that the universe we live in is just one of an infinite number of parallel universes, each branching off from the others with every quantum event. This idea isn't just a fun thought experiment, it's a serious scientific theory that helps explain some of the weirdest phenomena in quantum mechanics, like why particles can exist in multiple states at once until they're observed. The many worlds interpretation also plays a foundational role in the concept of parallel universes. It gives us a framework for understanding how multiple realities could coexist, and it challenges our traditional notions of time, space, and even identity. If every possible outcome exists somewhere, then the idea of a single, linear reality starts to crumble, opening the door to a cosmos that's far more complex and interconnected than we ever imagined. So, as we peel back the layers of quantum mechanics, we begin to see how the many worlds interpretation isn't just a theory, it's a gateway to understanding the infinite possibilities of the multiverse. And this is just the beginning. Next, we'll explore how the universe itself might be part of an even larger cosmic tapestry. Stay tuned. Now, let's shift our gaze from the quantum realm to the grand stage of the cosmos itself. Imagine the universe not as a single, isolated entity, but as one tiny bubble floating in an endless sea of other bubbles. This is the essence of cosmic inflation, a theory that takes the idea of parallel universes to an entirely new scale. Cosmic inflation suggests that in the earliest moments after the Big Bang, the universe underwent an exponential expansion, stretching faster than the speed of light. This rapid expansion didn't just create the universe we know, it also left room for other universes to form, each with its own unique set of physical laws and constants. Picture it like this: our universe is just one bubble in a vast cosmic foam, with countless other bubbles existing alongside it, each representing a separate universe. This theory didn't come out of thin air. It emerged from observations of the cosmic microwave background radiation, the faint afterglow of the Big Bang. Scientists noticed that the universe is remarkably uniform on large scales, with tiny fluctuations that hint at its rapid expansion. These observations fit perfectly with the idea of cosmic inflation, and they also open the door to the possibility of a multiverse. But how does this connect to parallel universes? Well, if inflation can happen once, it can happen again and again and again. Some scientists believe that inflation is an ongoing process, creating new universes all the time. These universes could be vastly different from our own, with different physical laws, particles, and even dimensions. In some, gravity might be stronger; in others, time might flow backward. The possibilities are as endless as the multiverse itself. What's fascinating is how cosmic inflation aligns with other theories we've discussed, like the many worlds interpretation. Both suggest that our universe is just one piece of a much larger puzzle. While quantum mechanics gives us parallel universes branching off from every decision, cosmic inflation paints a picture of universes existing side by side, each born from the same explosive beginning. So, as we explore the implications of cosmic inflation, we're not just talking about one universe, we're talking about a multiverse, a cosmic tapestry woven from countless threads of reality. And this is just the second reason scientists believe in parallel universes. Next, we'll dive into the mind-bending world of string theory and higher dimensions, where the multiverse takes on even more astonishing forms. Stay curious. Now, let's take a step into the fascinating world of string theory, where the very fabric of reality stretches beyond what we can see or touch. String theory is one of the most ambitious attempts to unify all the forces of nature, and it introduces a mind-bending idea. Our universe might not be limited to the three dimensions of space and one of time that we're familiar with. Instead, it suggests the existence of higher dimensions, hidden layers of reality that could hold the key to understanding parallel universes. At its core, string theory proposes that the fundamental building blocks of the universe aren't particles but tiny, vibrating strings. These strings can vibrate in different ways, giving rise to all the particles and forces we observe. But here's where it gets truly intriguing. For the math of string theory to work, it requires more than just the 4 dimensions we know. In fact, it suggests there could be as many as 10 or even 11 dimensions, all curled up and hidden from our everyday perception. So, how does this connect to parallel universes? Imagine these higher dimensions as a kind of cosmic landscape, where our universe is just one slice of a much larger reality. In this framework, other universes could exist alongside ours, separated not by distance, but by dimensions we can't access. These parallel universes might have entirely different physical laws, particles, and even forms of matter. Some could be almost identical to ours, while others might be so alien that they defy our understanding of physics. String theory also introduces the idea of brains, short for membranes, which are like sheets or surfaces floating in higher dimensional space. Our universe could be one such brain, existing alongside countless others. These brains might occasionally collide or interact, creating events so massive that they could leave traces in our own universe, like ripples in a cosmic pond. What's truly remarkable is how string theory ties into other ideas we've explored, like cosmic inflation and the multiverse. It provides a mathematical framework that not only supports the existence of parallel universes, but also suggests how they might coexist in a higher dimensional reality. While we can't yet observe these extra dimensions directly, the implications are staggering. Our universe might be just one page in an infinite cosmic book, with each page telling a different story. As we continue our journey through the mysteries of parallel universes, we'll next explore how the mathematical consistency of multiverse models adds another layer of evidence to this mind-expanding idea. Stay with us. The deeper we go, the more astonishing the possibilities become. Now, let's shift our focus to the power of mathematics, a language that has guided humanity's understanding of the universe for centuries. When it comes to parallel universes, mathematical models in physics play a crucial role in shaping our theories and predictions. These models don't just suggest the existence of multiple universes, they often require it to make sense of the cosmos as we know it. One of the most compelling aspects of these models is their consistency. Across different areas of physics, from quantum mechanics to cosmology, equations and theories repeatedly point to the possibility of a multiverse. For instance, the equations governing cosmic inflation, the rapid expansion of the early universe, naturally lead to the idea that our universe is just one of many. Similarly, string theory, as we've discussed, relies on higher dimensional mathematics that implies the existence of parallel universes. What makes these models so convincing is their ability to explain phenomena that would otherwise remain mysteries. Take the fine-tuning problem, for example. The constants of nature, like the strength of gravity or the mass of an electron, are perfectly calibrated to allow life to exist. Mathematically, the odds of this happening by chance in a single universe are astronomically low. But in a multiverse where countless universes exist with different constants, it becomes far more plausible that at least one would have the right conditions for life. Another key point is how these models align with observational data. While we can't directly observe parallel universes, the mathematical predictions they make about our own universe often match what we see. For example, the cosmic microwave background, the afterglow of the Big Bang, shows patterns that some scientists interpret as evidence of collisions between our universe and others. These findings don't prove the existence of parallel universes, but they do make the idea more credible. What's truly fascinating is how these mathematical models build on one another, creating a web of interconnected theories that all point toward the same conclusion. Whether it's through the lens of quantum mechanics, string theory, or cosmology, the math consistently suggests that our universe is just one piece of a much larger puzzle. As we continue to explore the evidence for parallel universes, we'll next delve into the fine-tuning problem and how it ties into the multiverse theory. The deeper we go, the more we realize that the universe, or universes, are far stranger and more complex than we ever imagined. Stay with us as we uncover more of these mind-bending possibilities. Now, let's turn our attention to one of the most intriguing puzzles in modern physics, the fine-tuning problem. This concept revolves around the idea that the fundamental constants of nature, like the strength of gravity, the mass of an electron, or the speed of light, are precisely set to values that allow life to exist. If any of these constants were even slightly different, the universe as we know it would be unrecognizable. Stars might not form, atoms might not hold together, and life as we understand it would be impossible. The odds of these constants aligning so perfectly by chance are astronomically low. To put it simply, it's like winning the cosmic lottery not just once but over and over again. This raises a profound question. Why does our universe have these specific values? Is it mere coincidence, or is there something deeper at play? This is where the multiverse theory steps in as a compelling solution. If our universe is just one of countless others, each with its own set of physical constants, then it's no longer surprising that at least one of them would have the right conditions for life. In this scenario, the fine-tuning of our universe isn't a stroke of luck, it's a statistical inevitability. Among an infinite number of universes, some would naturally have the perfect balance needed for stars, planets, and life to emerge. Think of it like a vast cosmic library. Each book in the library represents a different universe with its own unique set of rules. Most of these books might be filled with gibberish universes where the constants are too chaotic or unstable to support anything meaningful. But somewhere in that library, there's a book with just the right combination of words to tell a story. That's our universe. The fine-tuning problem doesn't just challenge our understanding of physics, it also invites us to rethink our place in the cosmos. If the multiverse theory is correct, then our existence isn't just a random accident, it's the result of a grand, interconnected tapestry of realities. As we continue to explore the mysteries of parallel universes, we'll next dive into the enigmatic world of black holes and how they might serve as gateways to other realities. The deeper we go, the more we realize that the universe or universes are far stranger and more complex than we ever imagined. Stay with us as we uncover more of these mind-bending possibilities. Now, let's venture into the mysterious realm of black holes, cosmic phenomena so powerful that not even light can escape their grasp. But what if these enigmatic objects are more than just destructive forces? What if they're portals to entirely new realities? This is where black hole cosmology comes into play, offering a tantalizing possibility. Black holes might be gateways to other universes. At the heart of a black hole lies the singularity, a point where gravity becomes infinitely strong, and the laws of physics as we know them break down. Some scientists propose that beyond this singularity, an entirely new universe could exist, complete with its own set of physical laws. Imagine stepping through a black hole and emerging in a reality where time flows backward, or where gravity is repulsive instead of attractive. It sounds like science fiction, but it's a theory grounded in the complex mathematics of general relativity. One compelling idea is that black holes could be connected to other regions of space-time through structures called wormholes. These hypothetical tunnels could link our universe to another, creating a bridge between two distinct realities. While wormholes remain theoretical, they offer a fascinating way to think about how black holes might serve as cosmic doorways. Another theory suggests that the interior of a black hole might not lead to destruction but to creation. Instead of collapsing into nothingness, the matter and energy swallowed by a black hole could give rise to a new universe expanding on the other side of the singularity. In this scenario, every black hole in our universe could be the seed of another, entirely separate cosmos. These ideas challenge our understanding of black holes, transforming them from cosmic vacuum cleaners into potential architects of new realities. While we don't yet have the technology to test these theories directly, they inspire us to think beyond the boundaries of our own universe. As we continue our journey through the mysteries of parallel universes, we'll next explore the holographic principle, a mind-bending concept that suggests our entire universe might be a projection from a higher dimensional reality. The deeper we go, the more we realize that the cosmos is far stranger and more interconnected than we ever imagined. Stay with us as we uncover more of these extraordinary possibilities. Now, let's shift our focus to a concept that might sound like it's straight out of a sci-fi movie, the holographic principle. This mind-bending idea suggests that our entire universe, with all its stars, galaxies, and even us, could be nothing more than a projection from a higher dimensional reality. Imagine the cosmos as a giant hologram, where everything we see and experience is just a two-dimensional representation of a much more complex, higher dimensional world. The holographic principle emerged from the study of black holes and the strange behavior of their event horizons, the point of no return where gravity becomes so strong that nothing can escape. Scientists discovered that all the information about matter and energy falling into a black hole isn't lost but is instead encoded on its surface. This led to the radical idea that our universe might work in a similar way, with all the information about reality stored on a boundary we can't see. So, how does this connect to parallel universes? If our universe is a holographic projection, it's possible that other universes could exist as projections from the same higher dimensional source. Think of it like a stack of movies playing on different screens, each one a separate universe with its own unique story. These parallel realities might overlap or interact in ways we can't yet comprehend, hidden within the fabric of higher dimensions. The holographic principle also challenges our understanding of space and time. If our universe is a projection, then the dimensions we experience, length, width, and height, might just be illusions. This opens the door to the possibility that other universes could exist in dimensions beyond our perception, each one a unique projection with its own set of physical laws. While this idea is still theoretical, it offers a fascinating way to think about the nature of reality and the potential existence of parallel universes. It reminds us that the cosmos might be far more interconnected and mysterious than we ever imagined. As we continue to explore the mysteries of parallel universes, our next stop will take us into the realm of the simulation hypothesis, a theory that suggests our universe might be nothing more than an advanced computer simulation. Could we all be living in a digital construct? Stay with us as we dive deeper into this extraordinary possibility. Now, let's step into a concept that feels like it's been pulled straight from the pages of a futuristic novel, the simulation hypothesis. This intriguing idea proposes that our entire universe, with all its complexity and wonder, might not be the base reality we assume it to be. Instead, it could be an incredibly advanced simulation, created by a civilization far more technologically advanced than our own. Picture this: every star, every planet, and even every thought you've ever had could be part of a vast digital construct running on some unimaginable supercomputer. The simulation hypothesis isn't just a wild thought experiment, it's grounded in some compelling scientific and philosophical arguments. One of the key points comes from the rapid advancement of technology. Think about how far we've come in just a few decades. From simple video games to virtual reality environments that feel almost real, it's not hard to imagine a future where simulations become indistinguishable from reality. If this trend continues, it's plausible that a civilization could one day create a simulation so detailed that the beings within it would believe it's real. But how does this connect to parallel universes? If our universe is a simulation, then it's possible that other simulations could exist alongside it. Imagine a vast network of simulated realities, each one running its own unique program with its own set of physical laws and histories. These parallel simulations might even interact or overlap in ways we can't yet comprehend, creating a multiverse of digital worlds. Philosophers have also weighed in on this idea, raising profound questions about the nature of existence. If we are living in a simulation, does that make our experiences any less real? And if there are other simulated universes, what does that mean for the concept of free will or the meaning of life? These questions challenge us to rethink our understanding of reality itself. Scientifically, the simulation hypothesis is difficult to test, but some researchers have proposed ways to look for evidence. For example, if our universe is a simulation, there might be tiny glitches or patterns in the fabric of reality, like pixels on a screen, that could reveal its digital nature. Others suggest that the fundamental laws of physics might have limits or anomalies that point to a programmed reality. While the simulation hypothesis remains speculative, it offers a fascinating lens through which to view the cosmos. It invites us to consider that the universe we know might be just one layer of a much larger, more complex reality. And if that's true, then the existence of parallel universes, whether simulated or not, becomes an even more tantalizing possibility. As we continue our journey through the mysteries of parallel universes, our next stop will take us into the realm of the brain multiverse, a theory that suggests our universe might be just one of many floating in a higher dimensional space. What secrets might these parallel brains hold? Stay with us as we explore this extraordinary idea. Now, let's shift our focus to a theory that takes the idea of parallel universes into a realm that feels almost like science fiction, the brain multiverse. This concept suggests that our universe might not be the only one out there. Instead, it could be just one of many universes, each existing on its own membrane or brain, floating in a higher dimensional space. Imagine our universe as a slice of bread in a cosmic loaf, with countless other slices, each a separate universe stacked alongside it. The brain multiverse theory is deeply rooted in string theory, one of the most ambitious frameworks in modern physics. String theory proposes that the fundamental building blocks of the universe are not particles, but tiny, vibrating strings. These strings exist in a space with more than the 3 dimensions we're familiar with, up to 10 or even 11 dimensions, depending on the version of the theory. In this higher dimensional space, our universe could be just one brain among many, each with its own unique set of physical laws and properties. One of the most fascinating aspects of this theory is how it explains the nature of gravity. In the brain multiverse model, gravity is the only force that can leak between brains, which might explain why it's so much weaker than the other fundamental forces in our universe. This idea opens up the possibility that what we perceive as gravity could actually be the influence of other brains interacting with ours. But how do these brains interact, if at all? Some theories suggest that collisions between brains could trigger events like the Big Bang, creating entirely new universes. Others propose that brains might oscillate or vibrate in ways that allow them to influence one another, potentially leading to observable effects in our own universe. While these ideas are still speculative, they offer a tantalizing glimpse into how the brain multiverse could reshape our understanding of reality. The connection between the brain multiverse and string theory is particularly compelling because it provides a potential solution to some of the biggest questions in physics. For example, string theory's higher dimensions offer a way to unify the forces of nature, and the brain multiverse gives us a framework to explore how multiple universes could coexist. Together, these ideas suggest that our universe might be just one piece of a much larger, multidimensional puzzle. As we continue to explore the mysteries of parallel universes, the brain multiverse theory reminds us that reality might be far stranger and more complex than we've ever imagined. It challenges us to think beyond the limits of our 3-dimensional experience and consider the possibility that there's an entire multiverse of brains out there, each with its own story to tell. Next, we'll dive into the cyclic model of the universe, a theory that proposes our universe undergoes endless cycles of expansion and contraction, potentially creating new universes each time. What does this mean for the existence of parallel realities? Stay with us as we unravel this fascinating idea. Now, let's turn our attention to a theory that paints the cosmos as a never-ending story, the cyclic model of the universe. This idea suggests that our universe isn't a one-time event but part of an infinite loop of expansion and contraction. Picture it like a cosmic heartbeat where the universe grows, collapses, and then starts all over again, potentially giving rise to new universes with each cycle. The cyclic model offers a fascinating alternative to the traditional Big Bang theory. Instead of a single explosive beginning, it proposes that our universe has gone through countless cycles, each one marked by a period of rapid expansion followed by a gradual contraction. During these cycles, the universe doesn't simply shrink back to a single point. Instead, it reaches a state where conditions are ripe for a new Big Bang, sparking the birth of a fresh universe. What makes this model so intriguing is how it ties into the idea of parallel universes. If the universe undergoes endless cycles, each one could produce a slightly different version of reality. Imagine a cosmic kaleidoscope where every turn creates a new pattern, a new universe with its own unique set of physical laws, constants, and even histories. This means that somewhere out there could be universes where the laws of physics are entirely different, or where events unfolded in ways we can't even imagine. One of the key pieces of evidence supporting the cyclic model comes from the study of dark energy, the mysterious force driving the universe's accelerated expansion. Some scientists believe that dark energy could play a crucial role in these cycles, acting as the engine that powers the universe's expansion and eventual contraction. If this is true, it would mean that dark energy isn't just shaping our universe, it's shaping countless others as well. But how does this connect to parallel universes? If each cycle creates a new universe, it's possible that these universes exist alongside one another, separated by time or higher dimensions. Some theories even suggest that collisions between these universes could leave behind observable traces, like ripples in the cosmic microwave background radiation. While these ideas are still speculative, they open up exciting possibilities for understanding the multiverse. The cyclic model also challenges our understanding of time. If the universe is caught in an endless loop, does time have a beginning or an end? Or is it simply a series of interconnected moments, each one leading to the next? This idea pushes us to rethink not just the nature of the universe, but the very fabric of reality itself. As we explore the cyclic model, we're reminded that the universe might be far more dynamic and interconnected than we've ever imagined. It's a theory that invites us to consider the possibility of infinite beginnings and endings, each one giving rise to a new universe with its own story to tell. Next, we'll delve into the enigmatic principle, a concept that explores why our universe seems perfectly tuned for life. Could the existence of parallel universes help explain this fine-tuning? Stay with us as we uncover this intriguing connection. Now, let's shift our focus to a concept that bridges the gap between the existence of life and the nature of the cosmos, the enigmatic principle. This idea suggests that the conditions of our universe are remarkably fine-tuned to support life, raising the question, why does our universe seem so perfectly suited for us? At its core, the enigmatic principle argues that the fundamental constants and laws of physics in our universe appear to be precisely calibrated to allow for the existence of life. For example, if the strength of gravity were even slightly different, or if the charge of an electron were altered by a tiny fraction, stars, planets, and life as we know it might never have formed. This fine-tuning has led scientists to wonder whether it's mere coincidence or evidence of something deeper. This is where the multiverse theory comes into play. If our universe is just one of countless others, each with its own unique set of physical laws and constants, it's possible that we simply exist in the one universe where conditions are just right for life. In other words, the enigmatic principle doesn't require our universe to be special, it just needs to be one of many possibilities. Think of it like this. Imagine a vast library filled with every possible book ever written. Most of those books might be gibberish, filled with random letters and symbols, but somewhere in that library there's bound to be a book that makes sense, a story that's coherent and meaningful. In the same way, the multiverse could contain an infinite number of universes, most of which are inhospitable to life. But in at least one of them, ours, the conditions are just right. The enigmatic principle doesn't just stop at explaining why our universe is the way it is. It also opens the door to deeper questions about the nature of reality. If there are countless other universes out there, what do they look like? Could some of them support entirely different forms of life, or even civilizations far more advanced than our own? Some scientists take this idea even further, suggesting that the multiverse might not just explain the fine-tuning of our universe, but also provide a framework for understanding the very nature of existence. If every possible universe exists somewhere in the multiverse, then our universe is just one piece of a much larger puzzle, a puzzle that we're only beginning to piece together. As we explore the enigmatic principle, we're reminded that the existence of life might not be a random accident but a natural consequence of a vast and varied multiverse. It's a perspective that challenges us to think bigger, to consider the possibility that our universe is just one of many, each with its own story to tell. Next, we'll dive into the mysterious force known as dark energy and its potential connection to parallel universes. Could this enigmatic energy hold the key to understanding the multiverse? Stay with us as we uncover the next piece of this cosmic puzzle. Now, let's turn our attention to one of the most puzzling forces in the cosmos: dark energy. This mysterious energy is believed to be responsible for the accelerating expansion of our universe. Yet its true nature remains one of the biggest unsolved questions in modern physics. But what if dark energy isn't just a feature of our universe? What if it's a clue pointing to the existence of parallel universes? Dark energy was first discovered in the late 1990s when astronomers observed that distant galaxies were moving away from us faster than expected. This discovery suggested that some invisible force was pushing the universe apart at an ever-increasing rate. Scientists named this force dark energy, but to this day, we still don't fully understand what it is or where it comes from. One intriguing possibility is that dark energy might be connected to the multiverse. Some theories suggest that dark energy could be the result of interactions between our universe and other parallel universes. Imagine our universe as a bubble floating in a vast cosmic ocean. If other bubbles, other universes exist nearby, their gravitational pull or energy fields might influence our own, creating effects we perceive as dark energy. Another theory ties dark energy to the concept of vacuum energy, a form of energy that exists in empty space. According to quantum mechanics, even a perfect vacuum isn't truly empty, it's filled with fluctuating energy fields. In a multiverse scenario, these energy fields could vary from one universe to another, with some universes having more vacuum energy than others. Our universe might simply be one where the amount of vacuum energy manifests as dark energy, driving its expansion. There's also the idea that dark energy could be a remnant of the Big Bang, a kind of leftover energy from the birth of our universe. If the Big Bang was just one of many such events in a larger multiverse, then dark energy might be a signature of those other cosmic beginnings. In this view, dark energy isn't just a feature of our universe, it's a thread connecting us to a much larger cosmic tapestry. While these theories are still speculative, they offer fascinating possibilities for understanding dark energy and its role in the cosmos. If dark energy is indeed linked to parallel universes, it could provide a crucial piece of evidence for the multiverse theory. It might also help us answer some of the deepest questions about the nature of reality, such as why our universe is expanding the way it is and what lies beyond the boundaries of our observable cosmos. As we continue to explore the mysteries of dark energy, we're reminded that the universe is far stranger and more complex than we often imagine. Could this enigmatic force be a bridge to other worlds, other realities? The search for answers is far from over, but each discovery brings us one step closer to unraveling the secrets of the multiverse. Next, we'll delve into the fascinating world of quantum entanglement and how it might hint at the existence of parallel universes. Could particles connected across vast distances be whispering secrets about other realities? Stay with us as we uncover the next chapter in this cosmic journey. Now, let's shift our focus to one of the most mind-bending phenomena in quantum physics: quantum entanglement. This strange and fascinating behavior of particles has puzzled scientists for decades, but it might also hold the key to understanding parallel universes. Quantum entanglement occurs when two particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. This connection defies our everyday understanding of space and time, as it seems to happen faster than the speed of light. Albert Einstein famously called it spooky action at a distance, and to this day, it remains one of the most mysterious aspects of quantum mechanics. But what if this spooky connection isn't just a quirk of our universe? What if it's a glimpse into the existence of parallel universes? Some interpretations of quantum mechanics suggest that entangled particles might actually exist in separate universes. In this view, when you measure one particle, its entangled counterpart isn't just far away in our universe, it's in a completely different reality. One such interpretation is the many worlds interpretation, which we touched on earlier. According to this theory, every possible outcome of a quantum event actually happens, but in different universes. So, when you measure an entangled particle, the result you observe is just one possibility, while the other outcome plays out in a parallel universe. In this way, quantum entanglement could be a bridge between our universe and countless others, each with its own version of reality. Another intriguing idea is that entangled particles might be connected through higher dimensions. String theory, for example, proposes that our universe exists in a higher dimensional space. If that's the case, entangled particles could be linked through these extra dimensions, effectively bypassing the limitations of our three-dimensional world. This could explain how particles remain connected across vast distances. They're not just separated by space in our universe, but are also connected through a hidden, multidimensional framework. The implications of this are staggering. If quantum entanglement is indeed a sign of parallel universes, it could mean that every decision, every event, and every possibility is playing out somewhere in the multiverse. It also raises profound questions about the nature of reality itself. Are we just one version of countless possibilities? And if so, what does that mean for our understanding of existence? While these ideas are still speculative, they offer a tantalizing glimpse into the mysteries of the cosmos. Quantum entanglement challenges our understanding of space, time, and reality, and it might just be one of the strongest hints that parallel universes exist. As we continue to explore this strange and wonderful phenomenon, we're reminded that the universe is far more complex and interconnected than we ever imagined. Could entangled particles be whispering secrets about other realities? The answer might lie just beyond the boundaries of our current understanding. Next, we'll dive into the Boltzmann brain paradox, a thought experiment that questions why we perceive an ordered universe and how the multiverse theory might provide an answer. Stay with us as we unravel another layer of this cosmic mystery. Now, let's turn our attention to a thought experiment that challenges our very perception of reality, the Boltzmann brain paradox. This paradox takes us into the realm of probability and the nature of existence, raising questions about why we experience an ordered universe instead of chaos. The Boltzmann brain paradox is rooted in the idea that, given enough time, random fluctuations in a chaotic system could produce a self-aware entity, like a brain, that perceives order where there is none. In other words, it's far more likely for a single, isolated brain to spontaneously form and perceive a false sense of order than for an entire, ordered universe to exist. So, why do we find ourselves in a universe that seems so structured and stable? This paradox becomes even more puzzling when we consider the multiverse theory. If the multiverse exists, it means that every possible configuration of matter and energy is realized somewhere in the vast expanse of parallel universes. In this framework, the existence of an ordered universe like ours isn't just a rare fluke, it's one of countless possibilities. The multiverse theory offers a solution to the Boltzmann brain paradox by suggesting that while chaotic, random universes might exist, so do ordered ones. In fact, the sheer number of parallel universes means that every conceivable arrangement of matter, from complete disorder to perfect order, is out there somewhere. Our universe, with its laws of physics and structured reality, is simply one of these possibilities. This idea also ties back to the anthropic principle, which we've discussed earlier. The anthropic principle suggests that we observe the universe we do because it's the kind of universe capable of supporting life. In a multiverse filled with every possible configuration, it's no surprise that we find ourselves in a universe where order prevails, allowing for the existence of conscious beings like us. The Boltzmann brain paradox forces us to confront profound questions about the nature of reality and our place within it. Are we the result of a highly improbable but stable universe, Or are we simply one of countless possibilities in a multiverse where every outcome exists? As we ponder these questions, we're reminded that the universe, or multiverse, is far stranger and more complex than we can imagine. The Boltzmann brain paradox doesn't just challenge our understanding of order and chaos. It invites us to consider the infinite possibilities that might lie beyond our own reality. Next, we'll explore the landscape of string theory, a concept that suggests a vast number of possible universes with different physical laws. Stay with us as we continue to unravel the mysteries of the multiverse. Now, let's shift our focus to the fascinating landscape of string theory, a concept that takes the idea of parallel universes to an entirely new level. String theory, one of the most ambitious frameworks in modern physics, proposes that the fundamental building blocks of the universe are not particles, but tiny, vibrating strings. These strings can vibrate in countless ways, each corresponding to different particles and forces. But here's where it gets even more intriguing. String theory also suggests the existence of higher dimensions, beyond the three spatial dimensions and time that we experience. In this higher dimensional space, string theory predicts a vast landscape of possible universes, each with its own unique set of physical laws and constants. Imagine this landscape as a cosmic terrain, where every valley, hill, or plateau represents a different universe with its own rules. Some universes might have stronger gravity, while others might have weaker electromagnetic forces. Some could be filled with exotic particles that don't exist in our universe, while others might be entirely devoid of life as we know it. This landscape of possibilities is not just a theoretical curiosity, it's a key piece of the puzzle when it comes to understanding the multiverse. If string theory is correct, then our universe is just one of an almost infinite number of universes, each occupying a different point in this vast landscape. This idea aligns perfectly with the multiverse concept, suggesting that the diversity of physical laws we observe, or don't observe, in our universe is just a tiny slice of what's out there. What's even more compelling is how this ties back to the fine-tuning problem we discussed earlier. In a multiverse filled with countless universes, each governed by different laws, it's no surprise that at least one universe would have the precise conditions needed for life to emerge. Our universe, with its finely tuned constants, might simply be one of the lucky ones in this cosmic lottery. The landscape of string theory doesn't just support the idea of a multiverse, it paints a picture of a reality that's far richer and more diverse than we could ever imagine. It challenges us to think beyond the limits of our own universe and consider the infinite possibilities that might exist in the higher dimensional fabric of reality. As we continue to explore the mysteries of the multiverse, the landscape of string theory reminds us that the universe, or universes, are far more complex and interconnected than we once thought. Next, we'll delve into the cosmic microwave background and how its anomalies might hint at collisions between our universe and parallel ones. Stay with us as we uncover more clues about the multiverse. Now, let's turn our attention to the cosmic microwave background, or CMB, a faint glow of radiation that fills the universe and serves as a snapshot of the cosmos just moments after the Big Bang. This ancient light holds secrets about the early universe, but it might also contain clues about something even more extraordinary: parallel universes. Scientists have long studied the CMB for insights into the origins and structure of our universe. However, in recent years, they've noticed something unusual: strange anomalies in the radiation that don't quite fit with our current understanding of cosmology. One of the most intriguing possibilities is that these anomalies could be evidence of collisions between our universe and other parallel universes. Imagine our universe as a bubble floating in a vast cosmic ocean. If other bubble universes exist nearby, it's possible that they could occasionally bump into each other. These collisions might leave behind faint imprints in the CMB, like cosmic fingerprints. Some researchers believe that certain cold spots or unusual patterns in the CMB could be the remnants of such encounters. One particularly fascinating example is the so-called cold spot, a large region in the CMB that's significantly colder than its surroundings. While there are several explanations for this anomaly, one compelling theory suggests it could be the result of a collision with another universe. If true, this would provide direct evidence for the existence of a multiverse, offering a tantalizing glimpse into the cosmic neighborhood beyond our own. Of course, these ideas are still speculative, and scientists are working hard to rule out other explanations. But the possibility that the CMB could hold evidence of parallel universes is an exciting frontier in cosmology. It challenges us to rethink not only the nature of our universe, but also the very fabric of reality itself. As we continue to analyze the CMB with increasingly sensitive instruments, we may uncover more clues about these mysterious anomalies. Each discovery brings us closer to understanding whether our universe is truly alone or just one of many in a vast multiverse. Next, we'll explore how probability and statistics play a role in multiverse theories, shedding light on why we observe the universe we do out of countless possibilities. Stay with us as we dive deeper into the science of the multiverse. Now, let's shift our focus to the fascinating role of probability in multiverse theories. When we think about the vastness of the cosmos and the countless possibilities it holds, one question naturally arises: why do we observe this particular universe with its specific laws and constants out of so many potential realities? This is where probability and statistics come into play, offering a framework to make sense of the seemingly infinite possibilities. Imagine standing in front of a cosmic lottery machine, where every possible universe is represented by a unique combination of physical laws, constants, and initial conditions. The multiverse theory suggests that all these combinations exist somewhere, but the one we inhabit is just one of many. So, why this one? The answer lies in probability. Some universes are more likely to support life, and by extension, observers like us. This idea is often tied to the anthropic principle, which states that the conditions of our universe must be compatible with the existence of observers. In other words, we find ourselves in a universe that allows life because, well, we're here to observe it. But probability goes even deeper. In the context of the multiverse, it helps explain why certain features of our universe appear finely tuned. For example, if the strength of gravity or the charge of an electron were even slightly different, life as we know it might not exist. In a multiverse with countless universes, each with different physical parameters, it's statistically inevitable that some universes would have the right conditions for life. We just happen to be in one of those rare, life-friendly universes. This probabilistic approach also ties into quantum mechanics, where every possible outcome of an event is realized in some universe. From this perspective, the multiverse isn't just a collection of random universes, but a structured landscape where probability dictates what we observe. It's like flipping a coin an infinite number of times. Every possible sequence of heads and tails will occur somewhere, and our universe is just one of those sequences. Of course, this raises intriguing questions about the nature of reality. If every possible universe exists, does that mean all outcomes are equally real? And how do we reconcile the idea of infinite possibilities with our own seemingly unique experience? These are questions that scientists and philosophers continue to grapple with, but the role of probability provides a powerful tool for exploring them. As we move forward, we'll delve into the concept of eternal inflation, a theory that suggests new universes are constantly being created in a never-ending process. This idea builds on the probabilistic framework we've just explored, offering even more insight into the nature of the multiverse. Stay with us as we continue to unravel the mysteries of parallel universes. Now, let's take a closer look at the concept of eternal inflation, a theory that takes the idea of the multiverse to an even grander scale. Eternal inflation suggests that the universe isn't just expanding, It's doing so in a way that continuously spawns new universes, creating an endless cascade of realities. This process isn't a one-time event but an ongoing phenomenon where pockets of space inflate rapidly, each giving rise to its own unique universe with its own set of physical laws and constants. Think of it like a bubbling pot of water where each bubble represents a new universe. As the pot heats up, more bubbles form, each one expanding and drifting away from the others. In the same way, eternal inflation proposes that our universe is just one bubble among countless others, all emerging from a vast, ever-expanding cosmic foam. This theory builds on the idea of cosmic inflation, which explains the rapid expansion of the early universe, but takes it a step further by suggesting that this expansion never truly stops. Instead, it keeps generating new universes in a never-ending cycle. One of the most fascinating implications of eternal inflation is how it ties into the idea of parallel universes. If new universes are constantly being created, each with its own unique properties, then the multiverse becomes a dynamic, ever-growing landscape of possibilities. Some of these universes might be strikingly similar to ours, while others could be wildly different, governed by entirely unfamiliar laws of physics. This endless variety raises profound questions about the nature of existence. Are there universes where time flows backward or where gravity works in reverse? Eternal inflation opens the door to these possibilities, suggesting that the multiverse is far more diverse and complex than we can imagine. But how does this process actually work? According to the theory, certain regions of space undergo rapid expansion due to a quantum field known as the inflaton field. As these regions inflate, they create pockets of space that eventually settle into stable universes, while the surrounding space continues to inflate, spawning even more universes. This creates a self-sustaining cycle where the multiverse grows exponentially over time. It's a mind-bending concept, but one that aligns with many of the observations we've made about the early universe, such as the uniformity of the cosmic microwave background radiation. Eternal inflation also has intriguing implications for the fine-tuning problem we discussed earlier. If new universes are constantly being created, each with different physical constants, then it's no surprise that some of them would have the right conditions for life. In this context, our universe isn't special, it's just one of many possible outcomes in an infinite sea of possibilities. This probabilistic approach helps explain why we find ourselves in a universe that seems so perfectly suited for life, without needing to invoke any external fine-tuning. As we continue to explore the mysteries of the multiverse, eternal inflation offers a compelling framework for understanding how parallel universes might arise and evolve. It's a theory that pushes the boundaries of our imagination, challenging us to think beyond the limits of our own universe. Next, we'll dive into the quantum suicide thought experiment, a fascinating idea that explores the relationship between observers and parallel realities. Stay tuned as we unravel even more layers of this cosmic puzzle. Now, let's shift our focus to a thought experiment that takes the concept of parallel universes into a deeply personal and philosophical realm, the quantum suicide thought experiment. This intriguing idea explores the relationship between observers and the multiverse, suggesting that our existence might be tied to the very fabric of parallel realities. At its core, the quantum suicide thought experiment asks a startling question. Could an observer, in some sense, never truly die because they always exist in a universe where they survive? To understand this, let's break it down. Imagine a scenario where a person is placed in a device connected to a quantum event, like the decay of a radioactive atom. If the atom decays, the device triggers a mechanism that ends the person's life. If it doesn't decay, the person survives. According to the many worlds interpretation of quantum mechanics, every possible outcome of this event creates a new universe. In one universe, the atom decays and the person dies. In another, it doesn't decay and the person lives. But here's the twist: from the perspective of the observer, they can only experience the universes where they survive. In other words, the observer is always in a reality where they continue to exist, no matter how many times the experiment is repeated. This leads to a fascinating conclusion. The observer might never experience death, at least not from their own perspective. While it might seem like a paradox, this idea aligns with the many worlds interpretation, which suggests that all possible outcomes of a quantum event are realized in parallel universes. The quantum suicide thought experiment pushes this idea to its limits, forcing us to confront questions about the nature of consciousness, identity, and reality itself. From a philosophical standpoint, this experiment raises profound questions about the nature of existence. If we are always in a universe where we survive, does that mean death is an illusion? Or does it simply mean that our consciousness is tied to the universes where we continue to exist? These questions challenge our understanding of life and death, blurring the lines between science and philosophy. Scientifically, the quantum suicide thought experiment also has implications for how we interpret quantum mechanics. It highlights the role of the observer in shaping reality, suggesting that our perception of the world might be deeply intertwined with the existence of parallel universes. While this idea remains speculative, it offers a unique lens through which to explore the mysteries of the multiverse. As we ponder the implications of this thought experiment, it's worth noting that it's not just a theoretical exercise, it's a tool for deepening our understanding of quantum mechanics and the nature of reality. It challenges us to think beyond the limits of our own universe and consider the possibility that our existence might be far more interconnected with the multiverse than we realize. Next, we'll explore the role of consciousness in multiverse theories, diving into how our perception of reality might shape the very fabric of parallel universes. Stay with us as we continue to unravel the mysteries of the cosmos. Now, let's take a step into the fascinating intersection of consciousness and the multiverse. The role of consciousness in multiverse theories is one of the most intriguing and debated topics in modern science. It suggests that our perception of reality might not be as fixed as we think. Instead, it could be just one of countless possibilities shaped by the very nature of our awareness. At the heart of this idea is the notion that consciousness might play a fundamental role in determining which universe we experience. Some theories propose that our minds act as filters, selecting one reality out of the infinite possibilities offered by the multiverse. In other words, the universe we perceive could be a direct result of our conscious observation. This idea builds on the principles of quantum mechanics, where the act of observation is thought to influence the outcome of events. But in the context of the multiverse, it takes this concept to a whole new level. One compelling theory is that consciousness itself could be a bridge between parallel universes. Imagine that every decision we make, every thought we have, creates a branching path of realities. In one universe, you might choose to take a different route to work, while in another, you stay home. But your consciousness, your sense of self, remains anchored to the reality where you made that specific choice. This raises the question, is our consciousness merely a passenger in one universe, or is it actively shaping the multiverse around us? Another perspective comes from the idea of quantum consciousness, which suggests that the brain operates on quantum principles. If this is true, then our thoughts and perceptions could be entangled with multiple universes simultaneously. This would mean that our awareness isn't confined to a single reality, but is instead spread across the multiverse, experiencing all possible outcomes at once. While this might sound like science fiction, it's a serious area of study for some physicists and philosophers who are exploring the boundaries of consciousness and reality. The implications of these theories are profound. If consciousness is linked to the multiverse, it could mean that our understanding of reality is far more fluid than we've ever imagined. It challenges the idea that there's a single objective universe and instead suggests that reality is deeply personal, shaped by the observer's mind. This also opens up fascinating questions about free will, identity, and the nature of existence itself. Are we truly in control of our choices, or are we simply experiencing one thread of an infinite tapestry of possibilities? As we explore these ideas, it's important to remember that they remain speculative. The connection between consciousness and the multiverse is still a frontier of scientific inquiry with more questions than answers. But what's clear is that these theories push us to rethink not only the nature of the universe, but also our place within it. They invite us to consider that our perception of reality might be just one small piece of a much larger, interconnected puzzle. With this in mind, let's turn our attention to the next piece of the multiverse puzzle, the evidence from particle physics. How do experiments at the cutting edge of science provide clues about the existence of parallel universes? Stay with us as we dive deeper into the mysteries of the cosmos. Now, let's shift our focus to the realm of particle physics, where some of the most advanced experiments in human history are shedding light on the mysteries of the multiverse. At the forefront of this exploration is the Large Hadron Collider, the world's most powerful particle accelerator. This colossal machine, located beneath the border of France and Switzerland, smashes particles together at nearly the speed of light, recreating conditions similar to those just moments after the Big Bang. But beyond uncovering the fundamental building blocks of our universe, these experiments might also hold clues to the existence of parallel universes. One of the key areas of interest is the search for particles or phenomena that don't fit within the standard model of particle physics, the framework that describes the known particles and forces in our universe. Scientists have long suspected that if parallel universes exist, they might leave subtle imprints on our own reality, perhaps in the form of unexpected particles, energy signatures, or even gravitational waves. The Large Hadron Collider is uniquely positioned to detect these anomalies, offering a potential window into other dimensions or universes. For example, some theories suggest that gravity, the weakest of the fundamental forces, might leak into our universe from neighboring dimensions. If this is true, experiments at the collider could detect tiny deviations in the behavior of particles that hint at the presence of these hidden dimensions. Similarly, the discovery of exotic particles, such as those predicted by supersymmetry, could provide indirect evidence of a multiverse. Supersymmetry proposes that every known particle has a heavier superpartner, and while these particles haven't been observed yet, their existence would align with theories suggesting multiple universes with different physical laws. Another intriguing possibility is the detection of miniature black holes. In some multiverse models, higher dimensions could allow for the creation of tiny black holes at energy levels achievable by the Large Hadron Collider. While these black holes would evaporate almost instantly, their detection would be groundbreaking, offering a glimpse into the physics of other universes. So far, no such black holes have been found, but the search continues, pushing the boundaries of what we know about reality. What makes these experiments so exciting is their potential to bridge the gap between theory and observation. While the idea of parallel universes often feels like the stuff of science fiction, particle physics provides a tangible way to test these ideas. Every collision in the Large Hadron Collider is like a mini exploration of the cosmos, probing not just our universe but the very fabric of existence itself. And while we haven't found definitive proof of parallel universes yet, the absence of evidence isn't evidence of absence. Each experiment brings us closer to understanding whether we're truly alone in the cosmos or part of a vast, interconnected multiverse. As we continue to push the limits of human knowledge, the evidence from particle physics reminds us that the universe is far stranger and more complex than we can imagine. And with every new discovery, we inch closer to answering one of the most profound questions of all. Are we living in just one of countless universes? Let's keep exploring as we turn next to the concept of time and how it might intertwine with the existence of parallel realities. Now, let's take a moment to consider the nature of time itself and how it might hold the key to understanding parallel universes. Time as we experience it feels linear, a steady march from past to present to future. But what if time isn't as straightforward as it seems? What if it's more like a vast, interconnected web where every moment exists simultaneously? This idea lies at the heart of the block universe theory, a fascinating interpretation of time that could provide a framework for the existence of parallel realities. The block universe theory suggests that time is not a flowing river but a static, unchanging structure. Imagine the entire history of the universe, past, present, and future, laid out like a giant block. In this view, every moment that has ever happened or will happen already exists within this block. This means that what we perceive as the present is just our current position within the block, while the past and future are equally real, just located in different parts of the structure. If this is true, then parallel universes could simply be other sections of this block, existing alongside our own but separated by dimensions we can't yet perceive. One of the most intriguing implications of the block universe theory is that it aligns with the idea of multiple timelines. If every possible outcome of every event exists somewhere within the block, then parallel universes could represent alternate versions of reality where different choices were made or different events unfolded. For example, in one timeline, you might have chosen a different career path, while in another, a historical event might have had a completely different outcome. These alternate timelines wouldn't be separate from our own, but rather part of the same vast, interconnected block. This idea also ties into the concept of eternalism, which posits that all points in time are equally real. From this perspective, the past, present, and future are not fundamentally different. They're just different coordinates within the block. If we accept this view, then the existence of parallel universes becomes almost inevitable. After all, if every possible moment exists somewhere within the block, then every possible universe must exist as well. This would mean that the multiverse isn't just a collection of separate realities, but a single, unified structure where all possibilities are realized. But how does this connect to the science of parallel universes? Well, if the block universe theory is correct, then the existence of parallel realities isn't just a philosophical idea, it's a mathematical and physical necessity. The equations that describe our universe often have multiple solutions, each representing a different possible state of reality. If time is a block, then these solutions could correspond to different sections of the block, each representing a parallel universe with its own unique set of physical laws and constants. Of course, this raises some mind-bending questions. If all moments in time exist simultaneously, does that mean our sense of free will is an illusion? Or could it be that our choices still matter, even if every possible outcome already exists somewhere within the block? These are questions that scientists and philosophers are still grappling with, and they highlight just how complex and mysterious the nature of time truly is. As we continue to explore the concept of time and its relationship to parallel universes, one thing becomes clear: our understanding of reality is far from complete. The block universe theory offers a compelling way to think about the multiverse, but it also challenges us to rethink our most basic assumptions about time, existence, and the nature of reality itself. And as we turn our attention to the next section, we'll dive into the role of mathematics in describing these multiple realities and how it might hold the key to unlocking the secrets of the multiverse. Now, let's shift our focus to the fascinating role mathematics plays in shaping our understanding of reality and how it might hold the key to unlocking the mysteries of parallel universes. Mathematics is often described as the language of the universe, a universal framework that allows us to describe and predict the behavior of everything from subatomic particles to galaxies. But what if this language isn't just describing one reality? What if it's revealing the existence of multiple realities, each governed by its own set of rules? At its core, mathematics is a tool for exploring possibilities. When scientists develop equations to describe the physical world, they often find that these equations have multiple solutions. Each solution represents a potential state of reality, a different way the universe could exist. For example, the equations of quantum mechanics don't just describe one outcome, they describe a range of possible outcomes, each corresponding to a different version of events. This multiplicity of solutions has led some scientists to speculate that these mathematical possibilities aren't just abstract concepts but actual realities, each existing in its own parallel universe. One of the most striking examples of this idea comes from string theory, a leading candidate for a theory of everything. String theory suggests that the fundamental building blocks of the universe are tiny, vibrating strings, and it requires the existence of extra dimensions beyond the three spatial dimensions we experience. These extra dimensions could house countless other universes, each with its own unique physical laws. The mathematics of string theory doesn't just allow for these parallel universes, it practically demands them. In fact, some estimates suggest there could be as many as 10 to the power of 500 possible universes within the string theory landscape. That's a number so vast it's almost impossible to comprehend. But it's not just string theory that points to the existence of multiple realities. Even in more familiar areas of physics, like general relativity, the mathematics often leads to the conclusion that parallel universes could exist. For instance, the equations describing black holes suggest that their interiors might contain entire universes, completely separate from our own. Similarly, the mathematics of cosmic inflation, the rapid expansion of the early universe, implies that our universe might be just one bubble in an infinite multiverse, with each bubble representing a different reality. What's truly remarkable is that mathematics doesn't just describe these possibilities, it seems to predict them. The consistency and elegance of mathematical models have led many scientists to believe that they're not just human inventions but fundamental truths about the nature of reality. If that's the case, then the existence of parallel universes isn't just a speculative idea, it's a mathematical inevitability. This raises an intriguing question. If mathematics can describe multiple realities, does that mean those realities actually exist? Some scientists argue that the answer is yes. They believe that every mathematically consistent universe is just as real as our own, even if we can't observe it directly. This idea, known as the mathematical universe hypothesis, suggests that reality is fundamentally mathematical in nature. In this view, the universe isn't just described by mathematics, it is mathematics. Of course, this idea is still highly speculative, and it challenges our most basic assumptions about what reality is. But it also offers a powerful way to think about the multiverse. If mathematics is the language of the universe, then parallel universes might simply be different sentences or paragraphs in that language, each describing a unique reality with its own set of rules and constants. As we continue to explore the role of mathematics in describing reality, one thing becomes clear: the universe is far more complex and mysterious than we ever imagined. Mathematics doesn't just help us understand the world, it reveals the existence of worlds we can't yet see. And as we turn to the next section, we'll delve into the philosophical implications of parallel universes, exploring how they challenge our understanding of identity, free will, and the very nature of existence. Now, let's take a step into the realm of philosophy, where the concept of parallel universes opens up profound questions about the very nature of existence. If parallel universes are real, what does that mean for our understanding of identity, free will, and the fabric of reality itself? These are not just scientific questions, they're deeply philosophical, challenging us to rethink what it means to be human in a multiverse. One of the most intriguing philosophical questions raised by parallel universes is the nature of identity. If every possible outcome of a quantum event creates a new universe, then there could be countless versions of you, each living a slightly different life. In one universe, you might be a musician, in another, a scientist, in yet another, someone entirely different. But which one is the real you? Are all these versions equally valid, or is there something that makes the version of you in this universe unique? This idea forces us to confront the concept of selfhood and whether identity is fixed or fluid across different realities. Then there's the question of free will. If every decision we make spawns a new universe, does that mean our choices are truly free, or are they predetermined by the branching paths of the multiverse? Some philosophers argue that the existence of parallel universes actually supports the idea of free will, because every possible choice is realized somewhere. Others suggest that it undermines free will because every outcome is inevitable in some universe. This debate touches on one of the oldest questions in philosophy. Are we the authors of our own lives, or are we simply following a script written by the laws of physics? Parallel universes also challenge our understanding of reality itself. If there are infinite universes, each with its own set of physical laws, then what we consider real might be just one possibility among many. This raises the question of whether reality is objective or subjective. Is there a single true reality, or is reality something that changes depending on where or when you are in the multiverse? Some philosophers have even suggested that the concept of parallel universes blurs the line between science and metaphysics, forcing us to reconsider the boundaries of what we can know and what we can only imagine. These philosophical questions don't just challenge our understanding of the universe, they challenge our understanding of ourselves. If parallel universes exist, then the story of who we are, what we do, and why we do it becomes infinitely more complex. It's a reminder that the universe is not just a place of physical laws and mathematical equations, but also a place of profound mystery and wonder. As we move forward, we'll explore the final piece of the puzzle, the search for observational evidence of parallel universes. What are scientists doing to find proof of these other realities, and what might that mean for our understanding of the cosmos? The answers could change everything we think we know about the universe and our place within it. Now, let's turn our attention to the cutting edge of science, where researchers are actively searching for tangible proof of parallel universes. While the idea of multiple realities has long been a staple of theoretical physics and philosophy, the quest for observational evidence is where the rubber meets the road. Scientists are using some of the most advanced tools and technologies ever created to hunt for clues that could confirm the existence of other universes. One of the most promising avenues in this search is gravitational wave detection. Gravitational waves are ripples in space-time caused by massive cosmic events, like the collision of black holes or neutron stars. These waves carry information about the universe's most extreme environments, and some scientists believe they might also hold hints of interactions between our universe and parallel ones. If two universes were to collide or brush against each other, the resulting gravitational waves could leave a unique signature, one that detectors like LIGO and Virgo might be able to pick up. While no such evidence has been found yet, the possibility remains tantalizing, and researchers are constantly refining their methods to improve sensitivity. Another area of focus is the cosmic microwave background, or CMB, the faint afterglow of the Big Bang. Some theories suggest that if our universe has ever collided with another, the impact could have left a bruise or anomaly in the CMB. Scientists have already identified a few unusual patterns in the CMB, such as the so-called cold spot, which some speculate could be evidence of a collision with a parallel universe. While these anomalies are still hotly debated, they provide a fascinating avenue for further exploration. Particle physics also plays a role in this search. Experiments at facilities like the Large Hadron Collider are probing the fundamental nature of reality. searching for particles or forces that might hint at the existence of other dimensions or universes. For example, if extra dimensions exist as predicted by string theory, they could influence the behavior of particles in ways that we might detect. While no definitive evidence has emerged yet, these experiments continue to push the boundaries of what we know. The search for observational evidence of parallel universes is not just about proving their existence, it's about deepening our understanding of the cosmos. If scientists can find even a single piece of evidence, it would revolutionize our view of reality, opening up entirely new fields of study and challenging everything we thought we knew about the universe. And while the search is still ongoing, the very fact that we're asking these questions and pursuing these experiments is a testament to humanity's unending curiosity and drive to explore the unknown. As we wrap up our journey through the 25 reasons scientists believe in parallel universes, it's clear that this idea is more than just science fiction. It's a profound and compelling possibility that continues to inspire researchers and dreamers alike. The search for answers is far from over, and who knows, the next big discovery could be just around the corner, waiting to reveal the secrets of the multiverse. As we bring our exploration to a close, it's remarkable to reflect on the sheer diversity of reasons scientists believe in parallel universes. From the mind-bending implications of quantum mechanics and the many worlds interpretation to the cosmic inflation theory that suggests our universe is just one bubble in a vast multiverse, the evidence is as varied as it is fascinating. String theory's higher dimensions, the mathematical consistency of multiverse models, and the fine-tuning problem all point to the possibility of other realities coexisting alongside our own. Black hole cosmology, the holographic principle, and the simulation hypothesis further expand the scope of this idea, challenging us to rethink the very nature of existence. Theories like the brain multiverse and the cyclic model of the universe offer even more layers to this cosmic puzzle, while the anthropic principle and dark energy provide frameworks for understanding why our universe might be just one of many. Quantum entanglement, the Boltzmann brain paradox, and the landscape of string theory all hint at a reality far more complex than we can currently comprehend. Even anomalies in the cosmic microwave background and the role of probability in multiverse theories suggest that the evidence, while indirect, is compelling. From the concept of eternal inflation to the quantum suicide thought experiment, the role of consciousness, and the search for observational evidence, the idea of parallel universes continues to captivate scientists and dreamers alike. Each theory, each piece of evidence adds another thread to the tapestry of our understanding, weaving together a picture of a multiverse that is as mysterious as it is awe-inspiring. So, as we stand on the edge of this vast cosmic frontier, one question remains: what if our universe is just one of countless others, each with its own unique laws, histories, and possibilities? The search for answers is far from over, and every discovery brings us one step closer to unraveling the secrets of the multiverse. What do you think lies beyond the boundaries of our reality? Let us know in the comments below, and don't forget to like, subscribe, and hit the notification bell to stay updated on the latest mysteries of the cosmos. The journey is just beginning, and the next revelation could change everything we know about the universe.